Good morning, ladies and gentlemen. This is another lecture on chemistry ScoreBooster, and it's going to be presented by Said Adewale. The topic of today is going to be on hydrogen. Last time we just had the general introduction of non-metals. So now, starting from today, we want to take those non-metals, at least those common ones. I want to take them one after the other and try to look at the occurrence and some important properties, and possibly their compounds and how they are prepared, their importance both in the industry or at home, or both, as the case may be. So we're going to talk about hydrogen, we'll talk about nitrogen and its compounds, we'll talk about oxygen, we'll talk about sulfur, we'll talk about carbon, we'll talk about phosphorus. At least we're going to spend quite a lot of time on this aspect, as I've said earlier. So let's start today with our lecture with hydrogen. Our aim for today, the general objective, is very simple and is not too much for today. It is just to be able to understand how to prepare hydrogen, its properties and some usefulness. Then you will now extend it to some compounds of hydrogen, at least some common compounds of hydrogen. So all those items to consider for hydrogen, like preparation, like occurrence, like properties, like usefulness, the area of application. So we extend it to some common compounds of hydrogen. So let's start off straight by the introduction. This is our usual periodic table, and this is hydrogen. It is placed here. Don't forget, during our discussion on periodic table, we justified the reason for putting hydrogen in group 1 and hydrogen in group 7. As a form of emphasis and a reminder, we said, since hydrogen contains one electron, and the number of electrons in the atmosphere determines the group to which an element is placed on the periodic table. Hence, hydrogen can be placed in group 1 because it has one electron. Definitely it has one shell, and again that shell is the outermost shell. Then with that, hydrogen that contains one electron in the outermost shell belongs to group 1. If somebody decides to put it on halogen group here in group 7, it is because all the group 7 elements, like fluorine, chlorine, bromine, and iodine, they have one electron short to complete the outermost shell. What are we trying to say? All of them has 7 electrons in the outermost shell, so to complete it they need one electron. So if you consider hydrogen as though it needs one electron to complete its outermost shell, then hydrogen can be placed in group 7. Those are the two reasons we put forward that time. But to avoid confusion, scientists put hydrogen anywhere here, so as to avoid confusion. So we want to study the hydrogen today. So, introduction. Hydrogen is the most abundant element in the universe. In fact, astronomers estimate it that 90% of atoms in the universe is hydrogen atoms. It's hydrogen atom. The argument being put forward is that the sun, and other stars, they are composed largely of hydrogen. Even according to them, hydrogen is a component of more compounds than any other element. And we have seen, even by volume, we have more water in the universe than soil, and hydrogen is an integral part of water. So that should tell us how abundant hydrogen is in the universe and how important it is. Hence, it is attracting this much attention. So, what are the most abundant compounds of hydrogen found on Earth? As I've explained. And also, hydrogen is an important part of petroleum. Some minerals and some organic compounds like cellulose, like starch, like sugar, like fat and alcohol and acid. There are some thousands of other substances that contains hydrogen. This makes hydrogen to be the most abundant element in the universe, because you can find it in almost every of the compound. At room temperature and pressure, hydrogen is a gas that is colourless. It is also odourless. It means if you put your your nose there, it can give any smell. It is tasteless. How you taste it, and it is non-poisonous. So they work with it easily in the laboratory. It is not poisonous, and every time it's present as a diatomic molecule. I remember I explained last time or 2 lectures ago why hydrogen is a diatomic molecule, because it is not easy to lose the electron, because hydrogen is a non-metal. It is not easy to lose electron because non-metals, they don't lose electrons. And if it is easy, hydrogen will have lost an electron and becomes another ion. But since it doesn't lose electron, then sometimes it gains, sometimes it shares. So if it wants to share to react with another hydrogen atom, since the other one will not lose electron also, and the two of them, their aim is the same, to complete the atom share. So it is the best thing for them is to share the electron. That is why hydrogen is stable as a diatomic molecule. And furthermore, we need to tell us that we have 3 isotopes of hydrogen. We have the protium, that is the proton. We have the deuterium, that is the heavy hydrogen. Then we have the tritium. Deuterium is common, tritium is from nuclear substance. They have similar chemical properties, simply because they contain the same number of electrons. So they have the same property like that, but they differ in physical properties. They differ in physical property because of the change in their mass number. So their number of neutrons are not the same, so they don't have the same physical properties, but the way they react is the same, because they contain the same number of electrons, and that electron is what is taking part in the chemical reaction. So let's talk about preparation of hydrogen. The first one we'll talk about is how hydrogen is gotten from steam and carbon, or sometimes hydrocarbons are being used. So if hydrogen is to be gotten from carbon, then there is what is called production of water gas, where steam will be passed over coke. Coke is a form of carbon. So when steam is passed over coke at a high temperature up to around 1000 degrees C, then there's going to be a mixture of carbon monoxide and hydrogen, because carbon is very good at reducing oxides. So when carbon reacts, it takes the oxygen away from the hydrogen. So carbon becomes carbon monoxide, then hydrogen gas is formed. This particular gas is what is called water gas. It is very, very important in petroleum, in petrochemical industry. Because it is used as a source of energy. When you want to power your generator, they use water gas as a source of energy. And again, if you want to produce more hydrogen, we can react this water gas with steam. When you react water gas with steam, CO will react with CO and hydrogen will react with steam further. Then CO will take oxygen away from the water to become CO2. Then two hydrogen will come together to form more hydrogen molecules. This is what is called water gas shift. So you shift water gas to form more hydrogen, but it is in the presence of catalyst. We can also use hydrocarbons with steam over nickel catalyst to produce hydrogen. One of the hydrocarbons that can be used is propane. We use propane C3H8. So if propane reacts with steam in the presence of nickel catalyst, there is going to be formation of carbon dioxide and hydrogen. So that is another way of producing hydrogen from hydrocarbon. We have talked about 3 ways now, but steam is the main player here. That is why I just put these two under steam and carbon or hydrocarbon. Another one is the electrolysis. Thank God we have done electrolysis before. So when you have a direct current that passes through that electrolyte, H2SO4 electrolyte. So if you have the H2SO4 aqueous, then you have SO4 minus and hydrogen. If you have hydrogen in the solution, you have hydroxide in the you have hydroxide in the solution, then you have hydrogen in the solution, you have SO4 in the solution. I'm not interested in going about the rudimentary of electrolysis now, because my aim is that you know electrolysis, you understand electrolysis. So, but as a form of reminder, let me just try to explain. So, when there is dissociation of H2SO4, the sulfuric acid, inside water, we have sulfate ion, then we have hydrogen ion. This is from H2SO4. Then from the water, we have hydrogen ion, we have hydrogen ion. So invariably, we have 3 types of ion now: the SO4, the hydrogen, and the proton. So we are not interested in what is happening at the anode, because our interest is on cathode. That is where hydrogen will be produced. So all the hydrogen will go to the cathode, they gain the electron, then hydrogen gas is produced. That is how hydrogen is being produced in the electrolysis. We are using electrolysis. Another important way is the reaction of metals with acid. Some metals that have lower reduction potential. Lower reduction potential means that all those metals are above hydrogen in the electrochemical series. So when they react with dilute acid, there is going to be displacement of hydrogen with the metal. Then hydrogen is liberated. This is the reaction. This one is coming from the metal and the acid. This acid they use here is HCl. So if you want to make it simple, just put HCl here. You put aqueous. This is H3O is from one of the hydrogens from this HCl. Then water, that is everything is dissolved inside. So ion will replace one hydrogen here. the ion will form. Ion will form another ion chloride also. Then you have hydrogen. This is our hydrogen. That is our interest. Hydrogen will be liberated. So the message now is, if you have a higher metal reacting with a dilute acid, then the metal will displace the hydrogen. You can write your own with H2SO4. You can write it with HNO3. But our interest in there is the hydrogen that will be produced. The fourth one is going to be the reaction of ionic metal hydride with water. Sometimes you have metal hydride, although this reaction is not common. It is only with metal hydride that have strong bonds, like calcium hydride, like sodium hydride, like potassium hydride. So aluminum hydride cannot be used in this case. So if you have this and it reacts with water, then there's going to be production of hydroxide, and this the base. This is the base. Calcium hydroxide is formed. Then we have hydrogen. Hydrogen gas that is from hydrogen is escaped. So how do we know when hydrogen is formed? It is a gas. There's no way we can collect it. I mean, with our hand, just collect it like as if we are taking solid. No. So they use what is called a glowing splinter. So when you have a glowing splinter that is placed very close to where hydrogen is escaping, then you light it, it's going to have a sound. When you hear that sound, that is a version of hydrogen. There are some reactions that hydrogen undergo. These reactions are very, very important, either in the home or in the industry. Hydrogen is used as fuel in driving our motor cars. So that reaction is important in the automobile industry. In production of margarine that is used at home, hydrogenation reaction takes place. That is a reaction that is important in the industry and also at home. There are so many other reactions that are important. We are going to see them during the course of this lecture. So hydrogen reacts with elements of group 1. The elements in group 1 are very, very reactive, like lithium, like sodium, like potassium, rubidium, cesium, and francium, to form hydride. When these elements react with hydrogen, they form hydride. Like sodium reacting with hydrogen directly to form sodium hydride, potassium reacting to form potassium hydride. So because the group 2 elements are not that reactive, there is only 3 of them that can react directly, with hydrogen, like calcium, like strontium, like barium. So when they react, then they form hydride of these metals. Then the compounds that is formed are crystalline in nature, or you know what is called crystalline compounds, when you have a regular repeating pattern in a compound, the substance. There are times that we have hydrogen reacting with a non-metal, such as oxygen, nitrogen, and the halogens. There are some other non-metals that can react with hydrogen. Their reaction is very, very important, and again, it becomes more explosive as the electronegativity of the non-metal increases. So now in this case, since we know that the electronegativity of non-metal increases the rate at which hydrogen reacts with that element, the readiness with the react. So it should really give a bell in our heads now that since fluorine is the most electronegative element, then reaction of hydrogen with fluorine will be the most explosive, because there's going to be a very large electronegativity value difference, which makes this reaction to be explosive. hydrogen can react with metal oxide to reduce the oxide to the metal. We have been encountering this reaction before in chemistry. So if you want to reduce copper oxide metal now, hydrogen is a very good reducing agent. Just pass hydrogen gas onto this compound, then you heat it in a closed container. When hydrogen passes over it, hydrogen reduces, takes away the oxygen, thus reducing the metal oxide into the metal. The hydrogen itself gets oxidized. That is one of the reactions of hydrogen also. Then apart from taking away the oxygen completely from the substance, from the compound, hydrogen can also take partially oxygen from the compound. This one is manganese oxide. So when hydrogen reacts with this manganese oxide, instead of taking away the oxygen completely, what hydrogen does is to reduce the oxidation number, the oxidation state of this magnesium inside this. In this case now it decreases from 4 to 2 in this case. So that is one of the most important reactions of hydrogen. So let's now go to compounds of hydrogen. We have known the usefulness of hydrogen now. We have highlighted the importance in the margarine industry. We have highlighted the importance in the automobile industry. There are many industries also that use it. So the first compound of nitrogen and of hydrogen that we're going to consider is the compound that involves hydrogen and nitrogen. The most common one is the ammonia. So ammonia is formed naturally when you have a nitrogen containing organic material that decomposes in the absence of air. There are many organic materials that contain nitrogen. Protein and its amino acids are the most common ones. So when any of these one now decompose in the absence of air, then we have ammonia. We can't rely on this alone. There are times that we need hydrogen in our laboratory. Even apart from that, the daily needs of ammonia is far higher than what we can rely on. Decomposition with in the absence of air of organic compounds, because nitrogen is a very important chemical in fertilizer industry. We use nitrogen to produce fertilizer. This nitrogen is very, very important. So we need to be producing it in the laboratory also. So the laboratory preparation of ammonia, the major one, is done by the reaction of ammonium salt. Any of the ammonium salt can be used with a strong base. A strong base can be sodium hydroxide, can be potassium hydroxide. So when you have an ammonium salt like ammonium sulfate, like ammonium nitrate, like ammonium chloride, you now react it with a strong base like sodium hydroxide. There's going to be a reaction between the acid and the base, because the ammonium salt will act like a weak acid in this case. So you now react with a strong base. Then there's going to be a chemical reaction like that. Then it gives ammonia. I expect you to write a balanced equation of this, because you know the product now. Ammonium salt, just take any of the ammonium salt, react with sodium hydroxide, then make sure ammonia is one of the products. Then you write other product that is remaining depending on the number of atoms that you have in your equation. Ammonia can also be prepared when you have ionic nitrides reacting with water. So this magnesium nitride is what we are using now to react with nitride. Then you have a base and ammonia. This is another production method for ammonia. Another one, the most commonly produced one on the commercial base, is the HBr process. This HBr process involves reacting directly nitrogen gas and hydrogen gas in place of catalyst. Usually ion catalyst is used here, then ammonia is formed. This last one it has been established, has been used for commercial production. Let's look at properties of ammonia. The physical properties now. Ammonia is colourless gas, but a very offensive odor. It's very, very soluble in water to give that liquid. It liquefies to give a colourless liquid. Even the rate of solubility of ammonia is almost 600 and something percent. So, as in, what I mean is, if you have 1 liter of water, you can dissolve almost 600 liters of ammonia gas into it. Is very, very soluble to a very large extent. Ammonia has a very high enthalpy of vaporization. Enthalpy of vaporization means it doesn't get vaporized easily. That is why it is being used as a refrigerant. So it is able to keep the temperature of the fridge as low as possible without getting evaporated. Some other useful compounds are derived from ammonia. It's just a matter of exchanging the one of the atoms of ammonia. The hydrogen. You can replace it with any compound or any atom. So if you replace it with a chlorine atom now, you have a chloramine. A chloramine is used in fumigation. If you replace one of the hydrogen with another ammonia molecule, you have hydrazine. So that is it. Ammonia acts as a Bronsted base. So when there is a reaction between ammonia or ammonium compound and a base, something must act as an acid, something must act as a base. So when it involves reaction of ammonia with a base, it acts as an acid. But most of the time, ammonia acts as a Bronsted base. Bronsted base is a proton acceptor. It is because of the lone pair of electron that is on the nitrogen. So nitrogen is almost always ready to accept the proton from other compounds, from other substance. That is why it is acting as a Bronsted base, because according to Bronsted defines its base as a proton acceptor. So nitrogen atom in ammonia has the lowest possible oxidation state of -3, because the formula is NH3. And don't forget our rules of finding the oxidation state of element. When you equate everything is equal to 0, and you know that hydrogen is +1, so by the time you move it to the other side, you have -3 for nitrogen. That is why it is lowest. So let's go to other compounds. In this case now we talk about phosphorus. There are many compounds that contains hydrogen and phosphorus, but the most important one is the one we're going to talk about now, the phosphine. If you look at it, phosphine and ammonia structurally, they look like each other, except that in the case of nitrogen, here we now have phosphorus. So that doesn't mean that everything that is happening with ammonia must happen with phosphine. One of the differences is that combination of elements to form phosphine is not possible in this case, but in ammonia it is possible when you just use ion catalyst, the fourth method just explained. You can combine them together and form ammonia, but in this case it is not possible. So phosphine is a colourless gas and very, very poisonous. So it means you can't handle it the way you can handle other some compounds that are not poisonous. So you have to be very, very important when handling it. It has a color like that of a decaying fish, so the color is offensive also, like we have it in hydrogen. With ammonia, that has a very sharp, pungent smell. So in this case is an offensive smell. So the composition of this is possible with heat. So when you have phosphine now decompose it with heat to form phosphorus and hydrogen. So the major use of this phosphine, like in chloramine, it is also used for fumigants, as a fumigant, and again the semiconductor processing, so you can use phosphine also. So like ammonia, gaseous phosphine unite with gaseous hydrogen halide, forming phosphonium compounds like I don't know how to even call it. In the case of ammonia, we call it chloramine. So in this case, I don't know how to call it. Maybe chlorophosphine and hydrophosphine. So they call it phosphonium. In this case, let's just take it as phosphonium compounds. Oh, sorry. This 4 is a subscript. This 4 is also a subscript. It is not a superscript like that, please. So let's look at methods of preparing it. There are 2 basic methods of preparing phosphine. The first one is the action of an acid with ionic phosphide. Ionic phosphide is ALP when you have aluminium reacting with phosphorus. When you now have this in an acid, a dilute acid, there's going to be production of phosphine. This is the first method. This first method is what is represented here in this equation. Somebody will ask me, how do we get aluminum phosphide? Aluminum phosphide is gotten from phosphorus and aluminium directly combined together. Another method is the reaction between white phosphorus and concentrated acid. When you have this phosphorus, don't forget the last time we talked about white phosphorus and red phosphorus. White phosphorus is the most stable one. This when it is heated to between 250 and 350, that's when you have red phosphorus. So in this case now, when you have white phosphorus reacting with concentrated base, this is the base. This is water that is used to dissolve them. So when you have this reaction, you have a phosphine produced. So these 2 general methods are the methods used to produce phosphine. Let's go to sulfur. The most important and most common compounds that contain hydrogen and sulfur is hydrogen sulfide, and this gas is a colourless gas. The taste, of course we can taste it, but the smell is offensive. Even when you smell it, it will be as if you are smelling rotten eggs. it is very toxic, like cyanide. In fact, in the laboratory they used to keep it in a special place in the laboratory because of its toxicity. Any attempt to just sniff it inside your nose like this for some time, you may end up not perceiving any smell again because of the damage, the light damage it can do to olfactory nerves. It destroys the nerves and the olfactory system. That's one of the problem with handling H2S, hydrogen sulfate. One of the methods of preparing it is direct combination of constituent elements. But the problem encountered by this method is the yield that is very small. Even at high temperature and pressure, the yield is very small, so they don't use it. So a more reasonable and effective way of producing it is when you have a metal sulfide that is very easy to get from the earth crust. You react it with a dilute acid. It can be any acid. You can have HCl, you can use H2SO4, you can use any acid. So when you now have that, there's going to be a reaction, then you have H2S will be produced. This is a very established method that is being used. So one of the usefulness is that it acts as a reducing agent. In the laboratory, it is a reducing agent. So a reducing agent gets oxidized to elemental sulfur when doing the reaction. When you have an oxidizing agent and reducing agent, you use hydrogen sulfide as a reducing agent. Then it reacts with an oxidizing agent, takes the oxygen away from it. Then the oxygen will combine with the sulfur to form oxide of sulfur. That is if there is excess amount of oxidizing agent. If there is no excess, you have elemental sulfur. But if there is excess, you have SO2 or SO3 depending on the excess. And if there is no water present, if there is water present, then you have SO4 minus, sulfate ion, or you have sulfite ion, SO4 or SO3 minus. That is if the water is present, because the water we have to dissociate. Then after the dissociation, we are going to be exchange of ions. But in this case, if you don't have water, you don't just have compounds like this. Then let's go to hydrogen with halogen. There are many examples of halogens. You can have bromine, you can have chlorine, you have iodine. So now, when you have compounds that contain two elements, in which one of them is hydrogen, the other one is halogen, this is called hydrogen halide. So all these hydrogen halide are gases at room temperature, and they are very soluble in water. Why they are soluble is because of the hydrogen bond that is between them. So the reaction of these halide compounds of hydrogen with metals, hydroxide or the oxide, even the carbonate, they produce salts of the halide. What we are trying to say is this: when you have like HCl now, you react with a metal, like let's say sodium, you are going to have salt of the halide. You have sodium chloride. The hydrogen will be liberated as a gas. That is what we are seeing here. If you have metal hydroxide like sodium hydroxide now, you react with HCl. You have the metal, the halide of the metal, that is sodium chloride, then you have the water. So what you have depends on what you produce. But the thing is, you will have sort of that halide. You can use hydrogen bromide as your own example because it's also hydrogen halide. When you have hydrogen bromide as your example, then you have sort of that hydrogen bromide. So most chloride are soluble in water. All the chlorides are soluble in water except these three, the silver chloride, the lead chloride, and the mercury chloride. They are the ones that are not soluble in water. I think I've explained this. Oh no, I've not explained this. So concept of solubility of this. But I think so. We are going to talk about all these ones later if we have not talked about them. Hydrogen halides are strong acids, all of them. But the exception we have is hydrogen fluoride is a strong compound. There is going to be a strong bond between hydrogen and fluorine. Don't forget I said hydrogen can react with non-metal, but the extent of the reaction depends on the electronegativity value of the non-metal. So in this case now, fluorine is the highest electronegative element. So when it reacts with hydrogen, it forms a very strong bond. So this strong bond makes it difficult for hydrogen fluoride to act as an acid, because acid produces hydronium ion. But since the bond between hydrogen and fluorine is now strong, it's even stronger than the bond that hydrogen will form with the water that is coming to produce hydronium ion. So hydrogen fluoride will remain as an hydrogen fluoride because of the strength of the bond. That is it. So let's look at ways of producing all these compounds. The first one is direct combination. I've explained all these areas. Just look at a way of producing them. Number one, if you want hydrogen chloride, you can react hydrogen, you can react with chlorine. So you have hydrogen chloride. If you have hydrogen bromide, you react hydrogen gas with a bromine gas in area where they react, then you form hydrogen bromide. So the same thing for iodide, same thing for fluoride. Another one is when you have a strong acid with a metal fluoride, a metal halide, like fluoride, like iodide, like chloride. When you have a strong acid, then there's going to be a replacement reaction. Then you have your hydrogen halide compound. So the reaction of concentrated sulfuric acid with a chloride salt produces hydrogen chloride. So if instead of this you use a chloride compound instead of fluoride, you have hydrogen chloride. If you use another compound, you get the halide of that compound. That is what this sentence is trying to explain. The problem with this is that hydrogen bromide and hydrogen iodide cannot be prepared with this sulfuric acid. This is simply because hydrogen H2SO4 is a very good oxidizing agent. Then instead of producing this, when you react, if you react sulfate, this H2SO4, very concentrated one, if you react with something like potassium bromide, instead of to form this, we are going to have something like oxidation. It won't form hydrogen iodide or hydrogen bromide. It will just oxidize it. Then you have your bromine inside the solution instead of to react with this. However, if you want to produce hydrogen bromide and hydrogen iodide, since we cannot use this method to produce them, then we use phosphate acid, H3PO4. This bromine is coming from it's going to be potassium bromide, it could be sodium bromide, it could be any bromide. You can use iodide also with your example if you want to practice. Then when we have reaction like this, there's going to be production of HBr and H2PO4. This H2PO4 is not stable, also you can react another thing is also. So let's talk about uses. HCl is an important chemical to manufacture glucose, to manufacture dyes, other valuable chemicals in the industry. HCl is very, very important. HBr is also important. HF is also important. Ammonia is important for the manufacture of fertilizer, even in production of nitric acid. Ammonia is very, very important, and these are all compounds of nitrogen, all compounds of, let's say, hydrogen, all compounds of hydrogen. We talk about usefulness of hydrazine before we talk about usefulness of chloramine. A considerable amount is also important for the activation of oil wells. So in the petroleum industry, when they want to lift oil, also they want to activate the oil, they use HCl to activate the oil. The petroleum engineers or the geologists, they know how they do it. Also, it is used as a pickle liquor. This pickle liquor is used as an is used like an acid to remove the oxide coating from iron. So in the earth crust, or when you have a passivation, I have explained what is called passivation. When there is oxide coating of the surface of metal, maybe you have a very reactive metal like aluminium now. When you have oxide coating of it, so that it will prevent the metal from reacting, it passivates it. Then you want to use the metal in metallic form. You can use the acid to remove the oxygen that's passivated. Then the metal is now used for what is being intended to be used initially. That is what we are trying to explain here. So this is the end of today's class. But let's talk about some reviews. Hydrogen is an element with one proton and one electron. We have explained that, and it can be placed in either group 1 or group 7 depending on the rationale to which the person look at it. And I said ordinarily hydrogen is not active. It is a gas, a non-reactive gas. So when you now want to activate it, you heat it. So there are many of these reactions that we have talked about, and some that we are even remember to talk about. Many of them are driven by heating. So when you heat them, then you activate it, the hydrogen reacts, whether with metal or with some non-metals. Then it reacts with some various elements to produce useful compounds. Yeah, thank you very much for listening to this class. We have talked about hydrogen now and its compounds. So by the grace of God, next time we are going to talk about nitrogen and its compounds. Thank you very much for listening, and don't forget to share and like our videos.